Giacomo Tanganelli. I'm also from Pisa.
In this webinar, we are going to present Instant BETaaS, which is a virtual machine we are providing as part of the collaborative project BETaaS to help software developers to build software for the BETaaS platform. We are going to show how to use it, how to install, and how to exploit the tools pre-configured and installed in the virtual machine to start writing software for the BETaaS platform. In the second part of the webinar, we will show how to how to integrate CoAP enabled sensors inside the BETaaS platform in order to have applications exploiting the services provided by these sensors.
Okay, so first of all, we have to go to the GitHub account of the BETaaS project. So you can see the URL inside the browser, and we can go into BETaaS platform tools, then BETaaS documentations, BETaaS docs, and finally GitHub. Inside the GitHub folder, you can find a lot of how-to documents. The one related to this webinar is the how to instant BETaaS. So we can open it. And first of all, we have to download the VirtualBox program from the Oracle website, and then download also the instant BETaaS image from link 1 or link 2. Once you have finished your download, you have to decompress it since it is a zip file, and you have to open the VirtualBox software. Inside the VirtualBox software, you have to go to Machine, Add, surf to where you have downloaded and extracted your file, and then inside the Instant BETaaS 2.1 release, you will find the VBox file we have to include in the VirtualBox manager. It's supposed to click on the open button, but we have already done it in order to speed up the presentation. So when you imported it, you will find the new VM in the left part of the VirtualBox program, and you can start by clicking on Start on the Start button. When the virtual machine is booted up, you will find the login manager, where you have to use as username and password the BETaaS.
So this virtual machine is an Ubuntu operating system on which BETaaS has been already installed and configured. Along with the BETaaS software to deploy a live BETaaS instance and a live running BETaaS gateway, there are a set of tools which can be used by software developers to start developing software for the BETaaS platform. Along with this set of tools, a set of utils to emulate real smart objects and to emulate other multiple BETaaS gateways has been installed and configured in order to help software developers to test the software they are programming.
Okay, so first of all, we'll show you how is the developer workflow. So we have already installed the Eclipse program inside the VM. So we can start the Eclipse program, and inside Eclipse you will find all the BETaaS platform already imported, as well as some example application that we will use during this webinar. As you can see on the left, there is the BETaaS platform, while in the bottom part of the menu, you can find the intrusion detection application, which we will use during this webinar. And as an example, we have the install thread opened, which is the file that performs the installation of application inside the BETaaS platform by exploiting a manifest file, which is used in order to communicate which are the things that the application needs to run. With the Eclipse framework, the developer can also modify the BETaaS platform, as well as create new model, and also compile it through the Maven program, which is already installed in the VM.
In order to, after making through the Eclipse tool a new application, a developer can start the BETaaS platform to test the application itself. At this aim, in the reminder of this first part of the webinar, we show how to run a live instance of BETaaS. In order to do that, first of all, we need to open a new terminal. And then we need to start Zookeeper.
Zookeeper is just a service registry which is used by the BETaaS platform.
After launching this command, the Zookeeper has started. After starting Zookeeper, what we have to do is to start CoAP. CoAP is a container for OSGI-based platform. The CoAP instance running in the virtual machine has been already configured to have all the bundles implementing the BETaaS software installed and pre-configured. As you can see, if we launch this command, list command, you will see the list of all the bundles already installed and configured in this CoAP instance. In particular, you can see here a bundle called BETaaS Adaptation Simulator, which basically is a simulator of smart objects, of things attached to the BETaaS platform. In order to facilitate the life of the software developers, this bundle has been included and installed by default in the virtual machine in order to help developers to start right away with the development of new applications, even if they don't have real smart objects or things. At this point, the developer can use this console to interact with the BETaaS instance and to interact with CoAP. In particular, if you type log tail, you can have a live output of the log of the BETaaS platform in order to check the status of the platform. At this moment, the platform is still initializing and is still loading some of the bundles. In a few minutes, in a few moments, what we will see is some output that will show how things are discovered. In particular, this output over here shows that a new thing has been discovered as a result of the thing simulator. In particular, we can see that a new sensor providing presence information with context information that locates it in the first floor of a house, in particular in the kitchen, has been recognized and installed. The corresponding thing service has been created in order to provide this service over here to applications. As the developers see this set of messages, the developer can assume that the platform is up and running and ready to host new applications. In particular, a new message is printed every time a new data is generated from the simulated sensor.
Since now the platform is ready, we can start the example application. And so we use the intrusion detection application that is a Tomcat web app which exploits attached presence sensor to detect intrusions. It uses the BETaaS API as been described in a previous webinar. And the application has been already installed and configured. So for security reason, we need to force the reinstallation process by modifying the application configuration file. In particular, you have to edit the file inside the web app folder of the Tomcat 7 server, and in particular the CFG file. So we open it with an editor and change the parameter is equal and set it equal to 0, as you can see here. So we change this parameter in order to force the reinstallation process, and we start again the Tomcat server. Okay, now when the server is started, we can open a web browser and open the URL of the intrusion detection application. So we find it in the localhost intrusion detection. Now, as you can see, the intrusion detection web interface shows is connected to the BETaaS platform and receive data from the sensors deployed inside the BETaaS platform. The web interface shows that now there isn't any presence detected.
So, so far we have shown how to run a BETaaS instance composed by only one gateway. For testing purpose, in some cases, this couldn't be enough. And software developers might want to test, for example, the scalability of the deployment of something in a more large environment where more than one gateway is included. For this reason, the BETaaS instance image includes also a virtualization framework called Linux containers that allows software developers to emulate a BETaaS instance composed by more than one gateway. In particular, if a browser is opened and the Linux container web panel is opened, and the developer logs in using the default username and password, which are admin. The Linux container web interface shows. From here, the software developer can launch multiple BETaaS gateways, each one already configured with the BETaaS software. A software developer can start 1, 2, or more gateways, can stop them, and can build an instance with more than 2 gateways, cloning the initial set of Linux container gateways. In the second part of the webinar, we will show how to integrate CoAP enabled sensor in the BETaaS platform. This procedure is well documented into an how-to published in the official GitHub account of the BETaaS project. In particular, the URL pointing to the CoAP plugin installation how-to is this one. This how-to illustrates step by step all the things a developer needs to do in order to enable a CoAP plugin and allow the BETaaS platform to interface with CoAP enabled sensors. In order to do that now, what we need to do is, of course, to stop the application. So in order to do that, we will stop the Tomcat framework. By default, the BETaaS platform is configured to have the thing simulator for the convenience of our software developers. In order to configure the CoAP plugin, what a developer needs to do is to build and install the CoAP plugin into the BETaaS instance. In order to do that, we go back to Eclipse. We move to the bundle BETaaS Adaptation CoAP, and we use Maven to produce the package. Maven install.
Once the process ends, we move back to the CoAP environment in order to disable the Things Simulator plugin. So we have to leave the log tail by issuing Ctrl+C, then perform a list operation in order to find out the bundle number of the Things Simulator, which in our environment is 235. So we stop the simulator, and following the how-to, we have to install 2 different bundles. The first one is the Californium, which is a Java CoAP framework that is used by the second bundle, which actually is the real CoAP adaptation plugin. So we install the first one and then the second one. inside CoAP. And at the end of the installation, we also need to start such bundle. So as we can see, the bundle are installed, but we have to start them. So need to start. Okay. Now let's leave CoAP and restart CoAP again. Okay. Now, in order to connect CoAP servers to the BETaaS platform, we also developed a simple CoAP server that you can find inside BETaaS utils. So let's go to Workspace, BETaaS Platform Tools, and then BETaaS utils, CoAP server. Okay, this CoAP server is a configurable CoAP server which is based on an XML file. As you can see, this XML file simulates a temperature sensor which is deployed in the kitchen located at the second floor. We can change this contents information in order to align it with the resources required by the intrusion detection system. So we changed the type to presence and also the floor to one which is the context information required by the intrusion detection application. We have to save this configuration file, and we have also to start the CoAP server by issuing java -jar and the target file, which is target CoAP server, then issue the 5cx3 as the default CoAP port and the config server.xml. One important thing, and it's worth to note that by default the CoAP adaptation plugin try to discover CoAP sensors running on localhost on the default CoAP port. So now,
in case you want to use a real sensor, you can modify the configuration of the CoAP plugin in order to look for CoAP resources in a sensor located anywhere in the world or in your local network.
Yeah, and now if you come back to the CoAP environment, and if we run logtail as before, we can see that the new CoAP sensor has been discovered as before, but now it's not emulated through the simulator, but it's an actual CoAP server. So if we start again the application, we will see that everything isn't changed. First of all, we have to reinforce the installation process by modifying the configuration file of the intrusion detection application, that is for security reason. And so we change it and we set it according to what we have done before. So we have to set is installed equal to 0. Then when you finish it with it, we can restart Tomcat server. And then open the browser on the same URL that we used before. And as before, the presence is not detected.
So for now, that's all. In this way, you can have a CoAP BETaaS instance connected also to real CoAP sensors. We have shown also how to do that using instant BETaaS. So from our side, it's all. I don't know if you have some of you have any questions or you have any comments on this.